we have one more lesson on the exponential models. In lesson 2, we talked about exponential growth and decay, and we talked about exponential functions, right? As far as like the initial value and the 1 plus or minus the rate to the t. So this formula, this interest rate formula, should look familiar. It is very similar to the a times 1 plus or minus r to the t. It is very similar to that. It just has some different letters, or it just has some different letters. So I listed them all here for you. The n is the only additional thing. So we're going to talk about today interest rate formulas, problems, types of problems. So when you have accounts, savings accounts, often banks will compound interest at different intervals. So rarely do you only get interest one times per year. Or if you're like making payments on student loans or cars or a home, they don't wait and only charge you interest one time a year. They charge it to you multiple times throughout the year. So N accounts for that. That's why it's called compound interest. So let's say you get $100 for graduation and you're going to put it into a savings account. And the bank will give you interest on that. They will pay you money for keeping your money with them. Compound interest means the next time let's just say you leave your money in there. The next time they give you interest, you will also earn interest on what they paid you last time. So that $100, you'll keep getting more and more interest, and they will continue to pay you interest on money that they have already paid you previously. So P in that spot, that is still your initial amount or your starting amount, but when we're talking about interest rates, we call it the principal. So principal means how much money you started with. R is the annual percentage rate. Again, you have to convert to a decimal, just like we did in lesson 2. N is the number of compounding periods. So how many times is it compounded per year? They will tell you annually, semi-annually, quarterly, monthly, weekly. They're going to tell you how often. That is N. And then this capital A is how much you have, whatever the value is after a certain number of years, and T is the number of years. So if your bank says, we will compound your interest annually, annual means year. So that means you are only getting it one time each year. So your N, your number of times, is 1. Semi-annually, semi means 2. If there are any shoppers, Nordstrom has a semi-annual sale that happens 2 times. Annually is a year. So 2 times each year. So your N is 2. Quarterly, so like quarter, right? How many quarters are there in a dollar? 4. There are also 4 quarters in a football game. There are 4 quarters in a year. So quarterly means 4 times every year. Monthly, obviously, a month is 12, or there are 12 months. So if you're getting it compounded monthly, that's 12 times. If the rate stays the same, so say the rate for each of these was exactly the same, the more often you get it, the better for you, because the more often they're paying you money on money that they've already given you. So it will earn more quickly. So we're going to do one of these. Well, we're going to do several of these. So say $3,000 is invested in an account that earns you $3,000 annual interest compounded quarterly. So quarterly means the number of times per year is 4. 3,000 is what you invest. That's how much you start with. That is your principal. And it earns you 3% annual interest. So 3% is your interest rate, but it's not the R that goes in your formula. The R in your formula, we don't put percentages in formulas. So we need to change that to a decimal. So just like in the lesson 2, if we change 3% to a decimal, I would move it 2 times to the left and get 0.03. So they're asking for the value of the account after 10 years. So 10 is T. So again, our formula is this. So you're going to have to be careful. We get lots of just like everybody gets things put in here correct, and then lots of little mathematical snafus. Okay, so the amount in our account, that's what we were trying to find. P is the principal. How much did we start with? We started with $3,000. 1. Notice it's just plus. If it's interest, you're only gaining interest, you're not losing. So we don't have to worry about are we adding or subtracting. R is 0.03. N, the number of times per year, was 4. To the N is 4 times T was 10. I cannot encourage you strongly enough to do some simplifying before you plug it into your calculator. If you have a phone, there's no way you should plug this whole thing into your calculator all at one time. I would simplify this part first. So 0.03 divided by 4, and then add it to 1. So in the parentheses, I get 1.0075. So do that part first, and then do the exponent first. 4 times 10 is 40. Now you can enter this. If you have a real calculator, you should be able to enter that whole thing in now. Use parentheses. Parentheses are your friend. Is $4,045.45. So you have added nothing more. You got $3,000, you put it in an account, and you let it sit there for 10 years and forgot you had it. And you come back after 10 years and you have earned $1,045 without ever putting another penny in there. Okay, next one. Luke is going to invest in an account paying an interest rate of 5.9%. So the rate is our R, but we need to turn it to a decimal. So R equals, if I move this decimal 2 places to the left, 1, 2, I get 0.059. How much would he need to invest? So this time is a little bit different. We're trying to figure out how much he puts in. So we are trying to find his initial amount, which is called the principal. We're trying to find P to the nearest cent. For the value in the account, that is the capital A, in 7 years. That is T, and I forgot to underline one, compounded monthly. Compounding, that's N, that's the number of times. If it's monthly, that is 12 times per year. So try to go through and label everything. Like if you're stuck, if you don't know exactly what to do, try to label everything and then put it into the equation and see if you can kind of figure out what you're supposed to do from there. So our end amount is $1,500. This time they're telling us how much we want to have. Maybe we're trying to save up to buy something. Equals, we don't know what our initial amount is. We need to figure out how much we should put in the bank to start saving. 1 always starts with 1, plus because we're making money. R, the rate, is 0.059 divided by how many times per year do we get interest? 12 times. And then the exponent is NT, the number of times, 12 times the number of years, 7. So just like in the last problem, don't try to put this whole thing in your calculator. As a matter of fact, you're really going to go wrong because you're trying to solve for this P. So you're going to want to simplify the parentheses and simplify the exponent. So 1,500 equals the principal This part in the parentheses, that 1 plus is 1.00492. And then 12 times 7 is 84. So since I'm trying to solve for P, I'm actually going to multiply this out, use my calculator to evaluate this, and then I will have to divide both sides by that. So in my calculator using this, I get 1.51024. That's a 2. I'm trying to solve for P, so I'm going to divide both sides by this decimal. That's a decimal. So I'm going to divide both sides by 1.51. On this side 2, which will get P by itself. And P is, let's see, to the nearest cent, $993.22. So that's how much you would have to invest into the account to have $1,500 in 7 years. This next one I kind of threw at you to see. At some point, you're going to need to be able to kind of identify which formulas. Sometimes that's the toughest part. As long as I'm only giving you one type at a time, you're like, okay, I can plug everything in. But on a test, they're going to be all mixed together. So I want to make sure that we address that. So if you look at this one, this one's back to a car like we did in lesson 2. It's depreciating, and they just give you a rate per year. It's not interest. It's not compounding, so it is not this formula up here. This is now back to the basic y equals a 1 plus or minus r to the t. So you really have to watch and try to figure out, you have to understand which equation is used for what. This stuff up here is only, only used if it's compounded interest. So they tell you that it's compounded quarterly or that it's compounded monthly. If they don't tell you that, then you don't use that equation. So Hazel purchases a car for $12,000. That's her starting amount. 12,000. We always start with 1. It's depreciating. That means losing value. When you buy a new car, it loses value. So we're going to subtract. If you buy a used car, frankly, it usually loses value. Our rate is 12%. So if we write that as a decimal, that's 0.12. And then to the t. Again, there's no n because it's not compounded. So 12,000. 1 minus 0.12 is 0.88, and then it's 4 years. Once you get it simplified like this, you should be fine using your calculator for the whole thing. So when she's done paying off her car in 4 years, it's only going to be worth a little over $7,000. So she just lost almost $12,000 in value of her car. Okay, the other type, which is not very common, to be honest, we wish that it was more common because it's a good deal for consumers, is compounded continuously. So just like I said with the compound interest, you only use this equation if you see the words compounded continuously. If you don't see continuously, don't use this. This is not it, okay? This is only compounded continuously. So we talked about monthly and weekly and daily. Continuous is like boom, 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 like all the time. It's always compounding, always, 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 which is why banks aren't going to give it to us because they're not going to pay us that much money. E is a button in your calculator. It is a number. So you need to find the E button. It might look like E with a little X or some kind of exponent. If you can find the word log in your computer or in your calculator, sometimes it's by that. You might have to use a shift to get to it. Look around somewhere on the left, probably. Look around. So P is still your principal. R is still your rate. T is still your time. T is a number. Okay. So Sue got $1,500 for graduation and she's going to invest it. That means that is our P. The account is compounded continuously. So we use this formula. Sometimes people call it PERT. Looks like PERT. That's the compounded continuously. The rate is 1.5. So as always, we're going to change that to a decimal, 0.015. So we move the decimal left twice. How much will she have in the account after 6 years? So 6 years is your time. How much is she going to have in the account? P, her principal that she invests, is $1,500. E is just a number E. And then the exponent is 0.015 times T, the number of years is 6. So you're going to have to kind of play around. You might want to multiply this first. Some calculators are different. So you're going to have to play. I'm going to tell you what it is and then practice on your calculator until you get it to do that. And if you're struggling to get it to work, then ask me in class and you can maybe share your calculator or something and I'll help you with it. So you should get $1,641.26. The last one that we're doing together, Regina invests $13,600. So she's investing that. That means that's P. The rate, we have to change it to a decimal, is 0.032. Compounded continuously, that means that we use that PERT formula, the E formula. What is the value of the account after 12 years? Years is T. And notice this one says round to the nearest dollar. Watch that. There will be lots of problems marked wrong in Delta and people will get angry. And I'll say, sorry. Especially on your test, right? That's a terrible way to lose a point. And you will lose a point. Okay. So the amount in her account is $13,600 times E to the exponent R times T times 12. So again, if you might want to simplify that exponent, multiply that out first. But you should get $19,966.80. These last couple, right? This is for you. I want you to try it. So it's just 3 different ones, different rates, different amounts of time, different formulas. I'm not going to go through them on here. I will share the answers with you in class, but I want you to try them and see what you get. And then we can check your answers when we are together in class.